Okay, for number 12, we are asked to use elimination method. That's the one where we have the different columns for x's, y's, and constants. The problem that we have here is that none of our columns match. We have a 7 and an 8, or an 8 and a 7, but none of them have the same coefficient. So we do have an issue there. We need to make them match. Now, it seems like it's pretty much the same no matter which one you choose to match. So I'm going to start by making the x's match. To do that, I'm going to go ahead and multiply the top by 8 and the bottom by 7. That'll give me 56x minus 64y equals 88. And 56x minus 49y equals 49. Now that the x's match, I can go ahead and eliminate. They match exactly. They're both a positive 56. So to make a 0 down here to eliminate, I would need to subtract 56 minus 56. Please remember that if I put this subtraction in front, it means that each column is a subtraction problem. So for the next column, negative 64 minus negative 49, I'm actually adding 49 to that. So when I'm done, negative 64 plus 49 is going to leave me with a negative 15y. 88 minus 49 is going to leave me with 39. At this point, it's a one-step equation. I need to divide by negative 15. So I end up with y equals negative 39/15. That can be reduced. 3 goes into both of these numbers, making this a negative 13/5. At this point, you have two options, and not everybody realizes that these two options exist. Most of you are very used to getting to the end, saying that's what y is, so let's plug this number into one of these equations, right? That's the usual process. What a lot of people do not realize, and we mentioned this, but it's been a few weeks. If you don't like the idea of plugging in a fraction like this and working with fractions, you can go back to the original problem and make the other variable match. You can redo the elimination method. So at the beginning, I made my x's match. I think it would be easier to just go back and make the y's match. That way I completely avoid plugging in a fraction. Especially a fraction like this. This is not a very normal, comfortable fraction to work with. So I'm going to go back to the original problem, and instead of multiplying by 8 on the top and 7 on the bottom, I'm going to do the opposite. I'll multiply by 7 on the top and 8 on the bottom. It'll give me 49x minus 56y equals 77, and 64x minus 56y equals 56. Now my y's match. Negative 56 minus negative 56 will make 0. So for the rest, I just subtract. 49 minus 64 is a negative 15x. 77 minus 56 is going to give me a positive 21. If I divide by negative 15 on both sides, I get that x equals negative, wrote it backwards, negative 21/15, which reduces down to be a negative 7/5. I have completely avoided plugging in this fraction for y, but I still found what x is. I have my two numbers, so I just write it x, comma, y. So that's a 5, it kind of looks like an 8 there.